Hey everybody, so this week we're going to look at logarithms. Well, it's kind of a scary word because you've never seen it before. I get it. So a log is just another way of writing an exponent. Okay, so we have, they're actually inverses of each other, which we'll look at in another couple days when we start graphing logs. All right, so in the log form, we have this, and it's read this way: log base b of a equals x. So log base b of a equals x. So if I want to switch that into exponential form, what we're going to do is we're going to start with the base, and we're going to raise it to this exponent. So whatever is over here on the other side of the equal sign, that's going to be our exponent, and then that is going to equal this a value. Okay, so log base b of a equals x is the same as b raised to the x power equals a. Okay, so we start with the base, this becomes our exponent, and this is what it equals. Okay, so taking that, we're just going to rewrite things to start with, and then I'll show you how we evaluate them. Okay, so we're going to start here. We're just going to convert these. So if you want to pause, write them down, then I will go through them. Okay, or just watch, that works too. Okay, so when I start here with log base 3 of 9 equals 2, we're going to convert that to our exponents, or our exponential form. So we start here with the 3, and we're going to take 3 and raise it to the second power, and that is going to equal 9, which is a true statement. 3 to the second power, 3 times 3 is 9, 9 equals 9. Okay, we're not worried about that part right now, we're just rewriting it. Okay, so this is our answer. In exponential form, these two things are equivalent, they're the same thing. All right? Okay, so try the next one, do the same thing. Log base 6 of 216 equals 3. So what number do we start with? The 6 is our base, and we're going to raise it to what power? The third power. So 6 to the third power means 6 times 6 times 6, which gives us 216. All right, same thing for number 3. 7 to the what power? To the 0 power equals 1. Anything to the 0 power is always 1. Any number to the 0 power, any number to the 0 power equals 1. It's been a long time since we talked about exponents, so we'll just refresh your memory. Okay. All right, this one looks a little different because it has two things that are different from what we've done so far. It has a fraction, and it also has a negative exponent. Okay, the process is still going to be the same when I change this into exponential form. We're going to start with the 4, and we're going to take 4 to the negative 2 power, and that's going to give us 1 over 16. Okay, so anytime you're taking a whole number and you want to change that whole number into a fraction using exponents, okay, you're going to have a negative exponent. So remember what we did was we said in order to make this a positive exponent, we bump it from the numerator, which it is here, we're going to bump it down into the denominator, and we get 1 over 4 to the second power, which is the same as 1 over 16. Okay, again, anytime you want to change a whole number into a fraction using exponents, your exponent will need to be negative. Okay, all right, so the next section asks us to go the other direction. So we're going to change our exponent, or our exponential form, into log form. So again, if you will pause for just a second, write down these examples, then we'll go through them. Okay. All right, so we're going to start with log of our base. The base is this number, the 14, of A is over here, 196, is going to equal whatever our exponent is. Okay, so the way I check it, because I think it's easier to go from this form to this form, from exponential into log, so it's 14 to the second power equals 196. 14 to the second power equals 196. I have it in the right order. Okay. All right. So how about this? How about you pause Can you rewrite the rest of these? And then we'll double check them. Pause, rewrite. Come on, you can do it. Okay, so 3 to the 4th power equals 81 is the same as log base 3 of 81 equals 4. Did you get that one right? Whoop, whoop. 36 to the 1/2 power equals 6. Okay, so just a side note here, whenever you take a number to an exponential power, it's going to make it smaller. So 1/2 power is the same as the square root, right? The square root of 36 is 6. So anytime you want to make a number smaller using exponents, you're going to use a fractional exponent. Okay, log base 36 of 6 equals 1/2. And again, our negative exponent is going to change it into a fraction. Log base 2 of 1/8 equals -3. Okay, I think I'm going to make a note over here. Okay, if I want to make a number smaller using exponents, okay, it's going to be a fractional exponent. Okay, to make a number smaller using exponents, we will have to use a fractional exponent, or our exponent will be a fraction. Okay, if I want to make a number into a fraction, so like this, if I want to make 2 into 1/8 from a whole number to a fraction, I'm going to use a negative exponent. Okay, and I think that will be helpful as we get into this last section of solving. Okay, that will come in handy. All right, so one other piece of information before we evaluate. We do have something called a common log. A common logarithm is a log with a base of 10, which is what our calculator is set in. So anytime you go to push the log button on your calculator, it's going to be base 10. Okay, your calculator at this point does not handle things other than base 10 for what we're doing. But if it's base 10, because it's common and that's the one that we use all the time, we can write it without the base, which is this number right here. So log base 10 of x is the same as log of x. So if you ever see something written like this where there's no base number in there, you can just go ahead and put a 10 in there if it makes you happy, okay? Or understand that it's just base 10 because that's our counting system that we use. All right, so we are going to evaluate a couple. And then we'll be done. Wow, this has gone quick today. Okay, evaluate the following logarithms. Okay, so this one is not just rewriting. This one is we need to figure out what number goes over here on the edge. So what I'm going to do is I'm going to put equals x, since that's what we're trying to find, right? We're trying to solve for this number. What is this equal to? Okay, so now if I rewrite this, that's going to say 7 to the x power equals 49. So 7 to the what power equals 49. And this is just use your brain. 7 to the first power, 7 to the second power, 7 to the third power. 7 times 7 makes 49. So that's going to be the second power. 7 to the second power equals 49. And you can double check that on your calculator if you need to. Right? Okay. So we're going to make this equal to x. Log base 3 of 27 equals x. So if I rewrite this, it's going to say 3 to the x power, or 3 to the what power, equals 27. So let's just come over here and just try it out. 3 times 3, that makes 9, right? So that's the second power. To the third power, 3 times 3 times 3, if we multiply that by 9 by 3, we get 27. There we go. 3 to the third power is 27. 11 log of 100. So what base is right here that we don't see? A 10, because that's our common log, and then that's going to equal x. So we're going to have 10 to the x power equals 100. How many times do I have to multiply 10 by itself to get to 100? 10 times 10, right? You're not going to have ridiculously huge values here either. They're going to be kind of small. Okay. All right. Can you rewrite the last one? 12 to the what power equals 1? How many times do I multiply 12 by itself to make 1? That's right, 0. Okay? Again, if you ever want to raise an exponent or raise something to an exponential value to make 1, the exponent will always have to be 0. Anything to the 0 power equals 1. Did we write that down? Any number to the 0 power equals 1. We sure did. In my book. Okay, so real quick, some of these special cases that we were talking about with the negative exponents and the fractional exponents, let's do these last two because they're just a little bit more of a challenge. Since this has been a really quick lesson, we're only at 11 minutes right now, so awesome. All right, so we're still solving our log, solving for x. So rewrite this. Log base 9 of 1 over 81 equals x. So that's 9 to the x power equals 1 over 81. Okay, so to take our base and to change it into a fraction, what kind of exponent do we need? To change our number into a fraction, we need a negative exponent. Okay, so I need a negative exponent that's going to change 9 into 81, essentially. 9 to the what power makes 81? 2? So 9 to the second power equals 81, but I don't want 81. I want it to be 1 over 81. So if I do a negative exponent, that's the same as 1 over 9 to the positive 2, which gives us the 1 over 81. Does that make sense? Okay, so our exponent here is negative 2. All right, and the last one, log base 64 equals 4, or sorry, log base 64 of 4 equals what number? So 64 to the what power equals 4. All right, so this one is getting smaller, so I'm going to look back at my notes. To make a number smaller using our exponent, we're going to have a fractional exponent. Okay, so here's how I want you to think about this. This is going to be a fraction, okay? So I need to know how many times do I multiply 4 by itself to make 64. 4 times 4 is 16. So if we multiply that by 4 again, that will make 64. So that's the third power. So 4 to the third power makes 64. So if I want to go the other direction, I'm going to do 64 to the 1/3 power, and that will give us back to our answer of 4. Okay, it is possible to have fractional exponents that are like 3 over 2 or 5 over 3, but for right now, we're just going to stick with a 1 over a number. We're not going to get too complicated with it. Okay, so it's kind of working backwards, right? Okay, awesome, y'all. I'll see you next time.